Next, we're going to look at forecasting models for time series of this type, where you have trend and random variations. And we'll be looking at two different models. One is an exponential smoothing model that adjusts for trend. The simple exponential smoothing model will consistently underestimate, and there will be bias in forecasting, and therefore it's not going to give you good forecast. So we have to adjust for trend. So we're going to look at that, and then we look at simple linear regression for trend projection. Okay, the formula involved in exponential smoothing with trend, there are two parts to it. So the first part is the same as the simple exponential smoothing, which is called smoothed forecast. Smoothed forecast is you take, so you have the forecast including trend, FIT. That's your final forecast. So forecast including trend, take that and then add a part of the error. So you're at the end of time period t looking into t plus 1. So you do have the value of y sub t. So find the error. A part of that error is added back to the previous forecast, and that becomes your first step. So that's not your final forecast, but that your textbook calls it smoothed forecast. Some people call it level. So level and then you trend. So the second part of the forecast is your trend. So you take, no, you're at the end of time period t. So you take what the trend portion was in the previous, or the time period that just ended, and then you use a second smoothing constant called beta. Okay, so you look at what is the difference between the new smooth forecast. Okay, how much has it changed, up or down? Okay, compared to the forecast of the previous period. So that change is the trend is adjusted with portion of that. So that's your trend for the next period. So you have the smoothed forecast for the next period, and the amount of trend that you need to adjust this with here, and then you add that. Uh, that's your final forecast including trend. So FIT is what we are after. So we have two parameters, smoothing constants, and both must be between 0 and 1. Alpha is for the constant part, beta is for the trend part. This example here, Midwestern Manufacturing electric generators sold. So we have demand for the past 7 years, and you can see the trend. And so simple exponential smoothing won't work. So let's now head on over to Excel. Okay, let's set up the data. Okay, let's go ahead and plot this data. Okay, usually finding a time before you start working on the model, you should really look at the graph and then see what the time series looks like. And you can see the trend here. All right, sales. Okay, all right, that's that. Okay, so now let's assume say 0.2 and 0.3 initial values, and we will do analysis with alpha and beta a little bit later. And once again, we need to, so to speak, prime the pump, and so we need the very first L sub 1 and L sub T sub 1. Okay, the first level and first trend. Okay, then only we can do the rest of the computations. So let's assume 74 and 0, okay, as our L and T. So the first L is that, and the first T is that. Okay. Now the forecast is T plus 1. Okay, so it will be that. Okay, it will be that plus the trend. So that's our forecast. Let's move that. And Now we can compute the error. So error will be the actual minus forecast. Okay. So once you have that, then we can set up the formulas for level and trend. Okay. Level is previous forecast, which is F14 plus alpha. So alpha must be absolute referenced times error. Okay. All right. So let's put a couple of decimal places there. And trend will be the previous trend. Okay. Plus beta, and again absolute reference that. Then you need the level minus the forecast. Okay, how much is the level different from the forecast, which is F14? Okay. Okay, so now we have set up the model. Now these four formulas can be copied. Well, all right, so now the forecast, you can go 1 over, so that will give you the forecast for, okay, let me put the border down. So that's the forecast for 2014. So that'll be F of 2014 and highlight 2014 to control 1 subscript. Okay. Now we can set up absolute value of the error. Okay, and put the border back, and then our MAD will be average of all that. So now we have the model set up. Okay. The next step is to do analysis with the model.